All right, so let's start. When you see MVT, it stands for mean value theorem, but don't have my bad habits. Try really hard not to say MVT. Say the whole expression, mean value theorem. If you say MTV, they're gonna get it wrong. That's a music channel, guys. Music television. It's mean value theorem, MVT. But try really hard not to say the abbreviation or the acronym. Try really hard to say mean value theorem. Yeah. Say mean value theorem, guys. Mean value theorem. Say it. Mean value theorem. Okay, good. So let's read this real quick and let's see what it says. It's a big deal, guys. So focus. All right, hold on.
Teachers and students, please pardon this interruption about the after-school activities being canceled, and any additional information that we need to share will be going out shortly. Thank you all. Have a wonderful Cardinal Day.
All right. Here we go, guys. Mean value theorem. Let's see what it says. This is a definition. And it says theorem 3. That's because we were using a textbook, but we're not keeping track of what theorems. Like the number of theorems, not but we are keeping track of the theorems, but the number. If y equals f of x is continuous at every point of the closed interval a to b and differentiable at every point on its interior a to b, then there is at least one point c between a and b at which f prime of c equals fb minus f of a over b minus a. What does all that mean in plain English? This on the right is an average rate of change from your Algebra 2 days, average rate of change. And this on the left is an instantaneous rate of change. Instantaneous rate of change. So, Chav, what does this mean in plain English? Tell me what it means. Let me tell you. Tell me why. Okay. It means if you were driving to South Padre Island, where it's nice and warm, or it might be cold, it's still cold, right? It's cold all over the state. If you drive to South Padre Island, your vehicle tells you your average speed, right? So if you drive to South Padre Island and you push a few buttons in your odometer, it's going to tell you that your average speed is 40 miles per hour. So all that means is at some moment between here and South Padre Island, your odometer, when you looked at it, was exactly at 40. Who knows? Maybe you had it in cruise control and it was 40 all the way. Or maybe you were going 20 in the beginning and then 70 and then you hit 40 somewhere in between. I guess the intermediate value theorem could also, but that's not it though. So all that means is that your instantaneous rate of change equals your average rate of change. And that's all. It just guarantees if your average rate of change is 40, your instantaneous rate of change was 40 somewhere along that interval. Somewhere. That's all it means. What does it mean in terms of pictures? I'll show you in terms of pictures. In terms of pictures, between A and B, you see the slope? That's the slope of the secant line. All that means is that I have a tangent line that has the same slope as the slope of that secant line. What example did I put here? Basically, it just means the instantaneous rate of change equals your average rate of change, given your conditions for you to use the mean value theorem. Okay, whatever. What does it mean in terms of pictures? Oh, here it is. There it is. And then I put a good example here. Let's see. Hopefully, you can see the graphical interpretation of mean value theorem. Yeah, I do such a bad habit of saying MVT all the time, of writing the acronym instead of saying it. Mean value theorem basically means that if you connect the endpoints of the graph on the interval with a chord, a secant line, there will be at least one point on the graph where the tangent line is parallel to the chord, meaning that the instantaneous rate of change is equal to the average rate of change. So that's all it means, guys, that your average rate of change is equal to your instantaneous rate of change. So your secant line has a tangent line that is parallel to your secant. So yeah, does that make sense? That's all it means. What two things have to be correct for you to use the mean value theorem? Continuous on the closed, differential on the open. It's not that bad. So let's go ahead and turn the page. See, look, we're already done with one page. So check it out. Not a trick question. Between A and B, can I use mean value theorem? No, why not? Not differentiable. Not differentiable right there. Not differentiable at this corner, comma, hence, comma, mean value theorem does not apply on interval bracket A, comma, B, bracket. You can put parentheses as well, but my interval is A to B, so I put brackets. And that's it. I don't even know if that's what I asked in there. The conditions of the theorem are of the extreme importance and cannot be ignored. If there's just one point on the interval in which f fails out, the conclusion of the theorem may not be true. Yeah, there it is. Now, it's possible that you might get an instantaneous rate of change that is equal to the average rate of change. Not in this case, because I wrote two linear segments. But the mean value theorem does not apply, period. Cool? Okay. Don't worry, guys. We're going to see some free response questions that they literally ask us if the mean value theorem applies. But we're not there yet. We're rookies, so we got to start with rookies. All right. Example 1. And we're going to go very slow, guys. Show that the function f of x equals x squared. I tried to make sure to use a baby function that we all know. That's just a quadratic, a parabola with the vertex at the origin. Satisfies the hypothesis of the mean value theorem between the interval 0 and 2. Okay, so here it is. I'm just going to draw between 0 and 2 this x squared. And I'm going to exaggerate it. Here's 0, and I'm going to say 2's right here. First, can I use mean value theorem? Are you continuous on the closed, and are you different? Yep, you can. So in case you're wondering, this is my secant line. And where does it look like I have a tangent line that is parallel to that one in purple? It looks like maybe right there. It looks like it might be. It looks like it might be right in the middle between 0 and 2. So it looks like maybe at 1. Let's verify it with our rule. So mean value theorem. So here it is. And don't become a robot. It's very easy for you to be a robot. That's my rule for mean value theorem. I'm just going to find the average rate of change, guys. So how do I do that? Well, this is 0. This is x equals 2. So I'm going to go f of 2 minus f of 0 over 2 minus 0. And see what that average rate of change is. I'll go here to the side. F of 2 equals 2 squared, which is 4. And I know you guys are smart enough that I don't have to do that on the side, but I wanted you guys to see it. 4 minus 0, 0 squared is 0, divided by 2. 4 divided by 2 is 2. This is your average rate of change. Average rate of change. Let's see where my instantaneous rate of change equals 2. So now I'm doing the left side of my MVT. So let me go ahead and circle it. What I did in red, that's this. What I'm doing in blue is the f prime of c. So I'm going to go f prime. I'm going to take the derivative of x squared, 2x. Nothing crazy, right? I equal 2x to the average rate of change, which is 2. So 2x equals 2. OMG, look at that. So that's your c value. So I guess technically you can say c equals 1, but c just means x value. Some specific x value. That's all the c means, some specific x value. So check it out. And we were correct. At x equals 1, you have a tangent line that is parallel to your secant line. And that's it. That's mean value theorem. At x equals 1, my instantaneous rate of change equals my average rate of change between 0 and 2. And that's it, guys. It's not magic. It's not anything magic.
Wait, so we're supposed to plug in 2 to the derivative?
No. You equal the derivative to your average rate of change, and you're solving for x. Right? So the left side is instantaneous. The right side is average rate of change. Yeah, ask questions, guys. I can't read minds. Ask me questions. It is a safe space. Hello, YouTube. Okay, I don't know what I was going to say to YouTube. So, anyways, all right, ready, guys? Look how simple this is. It's not that well. I shouldn't say simple. Look how what's a good word? Look, it's not that bad. Let's look at the logic. The function f graph below on the interval 0 to 10. Give the number of values c between 0 and 10, which is satisfy the. Okay, man, you need to stop using letters like c. So what they're saying is, tell me how many times I have a secant line, or I have a tangent line that is parallel to my secant line. Let me say it again because I'm going too fast. It says give the number of values c between 0 and 10, which draws the conclusion of the mean value theorem for f. So what it's saying is, how many tangent lines are parallel to the secant line? That's what it's saying. I just don't like that they use the letter c, because that's also part of your formula for MVT, see, for mean value theorem, where c is some x value. But they're not saying that. They want to know how many tangent lines are parallel to my secant line. So let's see what the average rate of change is. Here's at 0. Let me choose a different color besides red. Here it is at 0, x equals 0. Here I am at x equals 10. And I'm going to connect those two dots. Whatever the slope of those two dots is your average rate of change. Does that make sense, guys? All right. How many tangent lines are parallel to that green line? Well, it looks like I have one, let's see, like right, bam, like right there. Immediately after your max. And it looks like I have another one right, okay, it looks like I have another one right, boom, there. Do you guys see that? I'm just doing tangents. So I keep following the curve, and it looks like I have another one right. So right before your maxes, or right after your maxes, and right before your mins. So how many do you see? 3. That's the answer. How do we feel? Not bad, right? All right. Relax. Rolle's theorem is just a special case of mean value theorem. All Rolle's theorem is that your average rate of change equals 0. So find the instantaneous rate of change where it's 0. Now remember, okay guys, I don't want you guys to be robots. Focus, Miss Rowe. Remember, if your average rate of change is 0, that means that I'm looking for tangent lines that are horizontal. Does that make sense? Okay, so let's see what it says. So see, obviously, if your y value, okay, let me read it. And you will sometimes hear the Rolle's theorem. Rolle's theorem is a special case of mean value theorem in which the values f of a equals f of b. Here's the formal definition. And I wish I wouldn't have used this example. You know what? Let me put it in here. Change example for next year. Change example for next year. Because I don't want you guys to think that it has to equal 0 because no equals 0. All I'm saying is if I had a point like 310 and I'm continuous and I have a point like 510, notice my average rate of change is 0 between 3 and 5. Because it's just my secant line is literally a horizontal line, right? If you were to graph it. And of course, remember, we're talking about a continuous function here. So I'm just drawing 2 points. And look, your secant line is just a flat line. You guys know what I mean? Okay. So... yeah. All right. So, and of course, we have like some. So, what does your mean value theorem or Rolle's theorem say? That here it is. It's that point somewhere between 3 and 5. I made my graph super simple. Let's just do this, right? If f is continuous on a closed interval and differentiable on the open interval, that's mean value theorem. Those are the conditions that you need. And f of a equals f of b, then there exists at least one number c on the interval a to b at which the derivative is 0. All right. So let's see. Determine if Rolle's theorem applies to the function blah between 0 and 3. Okay. If you have a function, it's gonna apply because you're continuous and differentiable. Unless, well, okay, I got to be very careful. Unless you have absolute value or some type of function that has a corner or a vertical tangent. So maybe that's bad wording on my part. But if you have a polynomial like this, x cubed minus 9x, it's going to be continuous and differentiable. So it applies. We can use it. Cool or not cool? All right, let's find if Rolle's theorem applies. So I need to make sure that my average rate of change is 0 for Rolle's theorem. So I'm going to go f of 0 equals 0 cubed minus 9 times 0. So I get 0. F of 3 equals 3 cubed minus 9 times 3. So you get 27 minus 27. So I get 0. And like I said, this is a bad example. I'm going to change it for next year, but I stole this from UH. I don't want you to think that just because it equals 0, the rate of change is 0 because we're going 0 minus 0. But it could have been a different number besides 0. As long as the outputs are the same, Rolle's theorem would have applied. Why am I not? Yeah. Look, another one erase. That's fine. All right. Rolle's theorem applies. 0 minus 0 divided by 3 minus 0 does in fact equal 0. So Rolle's theorem applies. You can actually also say mean value theorem applies because but Rolle's theorem is a special case of mean value theorem. Are we okay, guys? All right. Here we go. So now what is it? Well, I got to find my derivative. My derivative of this function equals 3x squared minus 9. I'm going to equal the instantaneous rate of change because it is like an instantaneous rate of change for any x value. I'm going to equal that sucker to my average rate of change, which is 0. So I'm going to go 3x squared minus 9, and this is your c value, equals 0. I'm solving for x. Move the 9. 3x squared equals 9. Divide by 3. X squared equals 3. And then my last move, I got to take a what? Square root, x equals plus minus square root of 3. And be careful because some of you guys are robots and you just circle that immediately. we are only looking for between our interval. Because that's the condition. We're only looking in our interval. Is negative square root of 3 in our interval? No. So I'm going to write this only looking for x values in our interval between 0 and 3. So which one's the only one that I'm going to take? The positive square root of 3. So the positive square root of 3. That's the only one. Because the negative square root of 3 is not in our interval. And that's it, guys. And of course, we got to practice some more, and that's what we're going to do in a little bit with the delta. All right, so all you're doing is stating. It says simply state whether the conditions are met to use. And every time you see MVT, guys, just write it out. Mean value theorem. I need to change that. So next year, I'll go ahead and change my bad habits. All right. On this interval, negative 1 to 1, does the mean value theorem apply? Here's how this graph looks. Does mean value theorem apply in that interval? Why not? You're right. It does not. Why does it not apply? Perfect. Mean value theorem does not apply since f of x is not differentiable at x equals 0. Perfect. All you're doing is stating whether it applies or not. Does mean value theorem apply to this one? What do you guys think? Yes. Yes. Mean value theorem does apply since g of x is continuous on bracket 0, 1 and differentiable on parentheses 0, 1. I guess you can maybe even say continuous and differentiable on the close, but you want to put you want to say differentiable on the open. You don't want to include the endpoints for differentiability. And that's it. That's it. That's all you're doing. All right, let's go to the next one. Oh, I didn't put more MVT. That's it. Dang it. Okay. We'll practice some more tomorrow if we have school. We won't. Well, I feel indifferent, guys. I kind of want to be here. Even if we don't have school, I think if they have the campus open, I will be here because I feel like I need to. But you're not me, so you do you and I do me. All right. If f prime equals g prime at each point of an interval I, then there's a constant c such that, okay, so we were actually supposed to do this right before we left for the break, but we didn't. You already have experience. All this means is that all of your derivatives differ by a constant, or I guess the other way around, right? So here's what I'm trying to say. So look at all your antiderivatives differ by a constant. So let's say I have sine x plus 1, and then g of x equals sine x plus, what's your favorite number? 2. H of x equals sine x plus, give me someone else's favorite number. 12. All right, so look, guys, let's take a derivative of all of those. So f prime of x equals, what's the derivative of sine x? I was about to write sine x. Cosine x. What's the derivative of this one? Cosine x again. What's the derivative of this one? Cosine x again. Notice that all of the derivatives of sine x plus 1, sine x plus 2, sine x plus 12, all of them have a derivative of cosine x. So when you go the other way around, that's called an antiderivative. And notice that they all differ by what? By a constant. Yeah, we've said it before. So all differ all antiderivatives, let me write it all out. All antiderivatives differ by a constant. So if you have, so there it is, guys. So anytime you're doing the antiderivative of cosine x, you're going to say sine x. So okay, I guess here's what I'm trying to say. Yeah, I'll just say it instead of writing it down because we're going to have a whole bunch of examples anyways. Anytime you do the antiderivative of cosine x, antiderivative of cosine x, you're going to say sine x plus c. And you already know that because we've done it. But now we're kind of doing it formally. Cool or not cool? Cool. And yeah, so that's it. And then, of course, this is a condition, right? So let's read what this says. It says, find the function f of x whose derivative is sine x. So I'm going to write f prime of x equals sine x. And whose graph passes through the point 0, 2. Okay, so I'm going to go slow. What is the antiderivative? So I'm going to write f of x. What is the antiderivative of sine x? Yeah, it's what? Is it positive or negative? Negative cosine x, and then you got to put a plus what? Plus c, because it differs by some constant for all of them. They give me an initial condition for all of them, an infinite amount, right? They give me an initial condition, 0, 2. So when x is 0, the y value is 2. So that's what I'm going to plug in right here. So I'm going to go 2 equals negative cosine of 0 plus c. And then it's a little bit of pre-cal, but it's like baby pre-cal. Cosine of 0 is 1, and I have a negative there. So 2 equals negative 1 plus c. And then all I got to do is move that negative 1 to the other side. So c equals 3. Done. And you just go f of x equals negative cosine x plus 3. This is your specific function or specific antiderivative given the initial condition. And that's it. And you've done this before, so if you feel like this is similar, you've done it before. Why do textbooks use capital F of x to indicate antiderivative? I don't know. That's just the way the authors do them. You know what? I'm going to remove this for next year. So remove this because I don't use capital F, but a lot of textbooks do. All right, go to the next page. All you're doing is practicing for F. Practicing getting antiderivatives. So see, find all possible values of f with the given derivative. So if it says all possible values, you're just going to put plus c. Hey, no, Yanni, that's a demerit. It's not, miss. I'm kidding. All right, here we go. F of x. What is the antiderivative of x? Add 1 to the power. X squared over 2. Maybe some of you are already saying 1/2 x squared. That's fine. But add 1 to the power, divide by that number, and then I put a what? Plus c. There it is. How do you check yourself before you wreck yourself? Maybe you guys are too young to know about that. Take a derivative of 1/2 x squared and you'll get x. See? If you take the derivative of 1/2 x squared, you just get x, and the derivative of constant is 0, so it works. Does that make sense, guys? We're done with that. Go to letter B. What is the antiderivative of 2? 2x. And then plus what? Plus c. There it is. Done. See? Let's go to letter C. I'm going to go slow, guys. Relax. Antiderivative of 3x squared. I guess we'll do it in 2 steps. So let's go the long way. I'm going to write 3x to the what power? 3. And then I divide by 3. Minus, and I know some of you can probably already see it and like, Chop, why can't you just write x cubed? Yeah, if you can just see it, just go ahead. But we're rookies right now. And I'm going to write negative 2, and then I put x to the what power? 2, and I divide it by 2, and then plus 1x. And then I put a plus what? C. All right, so here's my function. Simplifying it, x cubed minus x squared plus x plus c. Yeah, and you can check. Check. Chop, how do you check? Take a derivative. The derivative of x cubed, 3x squared. Derivative of x squared, 2x. And there's a minus there. Derivative of x, 1. And the derivative of constant, 0. There it is. It works. Check mark. Do you guys see that? Okay. Letter D. F of x. What is the antiderivative of sine x? I hope I've been saying antiderivative. I've been saying antiderivative or I've been saying derivative. Okay. Yeah, what's the antiderivative of sine x? Negative cosine x plus what? C. And there it is. It works. If I take the derivative of cosine, it's negative, but it's a negative cosine, so it's a positive. Cool or not cool, guys? Cool. All right, go to letter E. Letter E is also E. What's the antiderivative of e to the x? E to the x, and then I put a what? Plus c. We might get you with this one. Maybe. We'll see. What is this antiderivative? Because it's not a polynomial and it's not an exponential. Oh, I think I heard someone say it. What is it? It is. It's ln. ln. And then this is your argument. So put all that in here. And we actually be putting absolute value, but I don't know if we know enough. Okay, yeah, we'll put absolute value. I'll tell you why. Plus c. And I guess what's my absolute value? This and this. So that one kind of looks like it could be it, right? All right, Chav, why are we putting absolute value when we didn't put absolute value when we're taking derivative of 1 over x? We put absolute value because 1 over x minus 1 has a domain, all real numbers except 1. So that absolute value allows us to have all real numbers except 1. Does that make sense? And okay, but Chav, how come? Okay, time out, guys. I'm going to go slow. How come when we take the derivative of ln of x like this, we don't put absolute value? Because ln of x, the domain of ln of x is all positive numbers. That makes sense? So we're only talking about positive numbers, so you have a domain restriction. We should be saying x greater than 0, this is my derivative, and then state the domain. But if you're going backwards, the domain of this one, the domain is all real numbers except 1. So when you go backwards, you got to put the absolute value to make all real numbers except 1. Does that make sense, guys? A little bit? Okay. And I know there's, okay, yeah, I'm not going to talk about that because I don't want to confuse you guys. All right. Yeah, so there it is, guys. And in case we don't have school tomorrow, we're going to practice, but this is informal. We will talk about the symbols. All right, ready? Relax. It's not that bad. This is the first time you've seen the symbols, or maybe you already know because you went to Khan Academy and you've seen these symbols when you're doing antiderivatives. That's an integral symbol. That dx is a differential. Relax. All it means is this. So let me write it here. Definition. Write this down. Write integral f prime of x dx equals f of x plus c. For now, relax. I'm going to talk about the proof. We're going to talk about the Fundamental Theorem of Calculus. We're just not there yet. For now, all you got to know is that this is the antiderivative. Look, integral symbol, f prime of x dx. Oh, okay. That just means antiderivative plus c. Don't worry. I'm going to talk about dx. I'm going to talk about that elongated s. We're just not there yet. So for now, we're fine just knowing that. Are we okay, guys? No one's like going crazy. Yeah, well, don't worry. Very soon, we're going to talk about something called Fundamental Theorem of Calculus, and we're going to talk about where the differential goes, what is it, all that good stuff. All right, here we go. Antiderivative of this guy. So I'm going to go integral, and I'm going to rewrite this as, I guess, timeout, because I bet you. All right. If you were to look at this, would you just say, well, that has an x squared on the denominator, that's ln of x squared. Would you say that? That the antiderivative of that is ln of x squared? Job, I don't know. It's not. The only time, and then write this down, the only time the antiderivative is an ln, the denominator has to be linear. The denominator has to be a linear expression. Job, what are you talking about? Look. See how this denominator was a linear expression? So the antiderivative of this is ln of x minus 1. But if let's say I would have written an x squared, what if I would have written 1 over x squared minus 1, is the antiderivative still ln of x squared minus 1? No. Then you need to do that with partial fractions. That's Cal 2. So you would have to do 1 over, x plus 1 over plus 1 over x minus 1, or a over. Anyways, we're not in Cal BC, except for some of you. But we're not going to talk about that until we get there. Are we okay? Okay, so it's only ln if the denominator is a linear expression. So make sure you write that down somewhere. So child, then how do I do it? Like this, guys, just bring up the x squared like in algebra 1. Go 2x to the negative 2 dx. See? This is your f prime. This guy right here. That's your f prime of x. I'll put a negative. 2x to the negative 2. See, that's your f prime right there. So I'm going to find my antiderivative. So how do I do that? I take this polynomial, I take that exponent, I add 1, and I'm divided by that number. Does that make sense? So here it is. I'm saying this is going to equal, I'm going to go slow, 2x, what's negative 2 plus 1? Negative 1, and I divide by that number, negative 1, plus c. What's positive divided by negative? So there it is. So I'm going to write it like this. Negative 2 over x plus c. And there it is. This is my antiderivative of that. If you take the derivative of that, you do get 2 over x squared, or 2x to the negative 2. Does that make sense? Ask me, Kanduru. Ask me.
I don't know. Can you just do it again?
Yeah. Well, okay. See how this, I'm saying that's my antiderivative, right? So I'm saying that this is f of x. So look, yeah, don't write this down, guys. Just listen. If I were to take my derivative, this right here is just negative 2x to negative 1. So how do I take a derivative? Negative 2 times negative 1 is a positive 2. And I subtract 1 from the exponent, x to the negative 2. And then that's a constant, so it goes away. Oh, look, 2 over x squared. Yeah, that's what I have in there. Ask me, Kunduru. Because I'm doing an antiderivative. So how do I prove that this is that? If I take a derivative, I better get this expression. See, look, it says f prime in there. That says f on the outside. And there's an equal sign right in between. So I can go back and forth all I want. Antiderivative, derivative. Antiderivative, derivative. Well, that x squared, I brought it up, and it became negative. Laws of exponents.
So when negative 2, like the exponent is negative, y is equal to
I added 1 and divided. And positive divided by negative is a negative.
But if you added 1, why do we divide by negative 1?
I divided by the exponent. I'm going backwards.
Yeah.
Take the negative 2, add 1,
Oh.
and then divide by negative 1.
Yes, yes.
Okay. Okay. All right, guys. Don't relax. Look at the next one. The only thing that's going to stop you guys is your algebra. But hopefully we've been tackling your algebra for a while now. Look at the next one. Relax. Chav, it's a quotient. I don't know how to do antiderivative. Okay, you're not going to bother with any of that stuff yet. We're rookies if you're trying to figure that out. You're going to break this up with algebra. Are we okay? So look, go to the side and do this. 3x cubed over x squared minus 4 over x squared. So break it up into something that you know how to do. Something that you can break up. Oh. I feel like Ariana Grande. Break up with your friend. Okay, sorry. All right, here we go. Ready? I'm undoing his algebra, guys. Undoing his algebra. X squares cancels out. I take out 2 of those. Now that becomes x to the power 1. And then I'm going to bring that x squared up to make life easier. So I have this, 3x minus 4x to the negative 2. So here's what I'm going to do. I'm going to write the integral symbol because that's just part of my, for now, that it really stands for sum. But I'm going to write my integral symbol, and I'm going to write 3x minus 4x to the negative 2 dx. And I kind of want to put parentheses, but we don't know any better, so we're not going to do that. You guys ready? Add 1. That's a 1 right there. Add 1 to that and divide by that number. We're doing the opposite of the power rule. So 3x squared, and I'm going to divide by 2. Do you see what I did? Minus, and then we're going to add 1 to that exponent and then divide by that number. We're doing the opposite, reverse and opposite of, just reverse. Reverse and opposite of product rule. So 4x to the negative 1 divided by negative 1. And then plus c. You got to put the plus c in there, guys. So let's see. Let's make it pretty. So this is 3/2 x squared. You can leave it like this. This is also pretty. And then negative divided by negative is so plus 4 over x to make it look like how we had it over here. Plus c. There it is. I guess I could have found a common denominator there if I wanted to. How are we feeling, guys? Okay. Yeah, look, don't worry. We just got 2 left, and then we'll be done. And then you'll just practice. All right. Here. Let's see if we can just go right into it. Antiderivative of 3x squared. Add 1, divide by that number. So what is that? See, 3x cubed divided by 3, the 3's cancel. Does that make sense? All right, let's go to Chav. What about this one? I don't know. Okay, side note, that's the same thing as 7x to the half. So here we go. Plus, add 1 to the half. That turns to what? 7x to the 3 halves. And I'm going to divide by 3 halves, which is the same thing as multiplying by 2/3. I'm going to put a little dot in between. And I'll write what I put in there. Divide by 3 halves, which is same as multiplying by 2/3. Divide by 3 halves, which is same as multiplying by 2/3. All right, this one right here, guys, relax. Side note, that's x to the -3. So I'm going to put plus. So I'm going to add 1 to that -3. That's what? -2 and divide by -2. You could also say multiply by -half, which is the same thing, right? Comes out to the same thing. All right, you guys ready? Oh, plus what? C. Always a plus C. Are we okay? All right, I'm just making it pretty now. X cubed plus 2 times 7 is, and it does not simplify, so you can say 14/3 with the x to the 3 halves like that. Or you can say 14x to the 3 half all over 3. It doesn't matter. Whatever you think is easier. Minus 1/2. I guess the x squared goes to the bottom. Over x squared plus c. And there it is. That's it. I guess if you don't like that, you can write the x to the 3 halves with the 14 up there. X cubed plus 14 x to the 3 halves over 3 minus, to be consistent. But you don't have to. You don't have to. They're both the same. Delta should count them both right. If you were doing it on the AP exam, they're counted both right. All right. Last one. Make a side note. 1 over x squared is the same thing as x to the -2. I'm not taking derivative. I'm just rewriting it. 2 over x cubed is the same thing as 2x to the -3. And I'm not doing that with 1 over x because we already talked about what that antiderivative of that is. I'm going to go slow. Antiderivative of 1 over x. ln. And I put a what on it? An absolute value. If you don't, that's fine for now because we're rookies, but your professor's going to want that absolute value. And then I'm going to put a plus. And don't worry, we'll worry about what the sign should be in front if you want to make it pretty. I'm doing the antiderivative of 1 over x squared, so that's this guy. So we're going to add 1 to that exponent. -2 plus 1 is, and we're going to divide by -1. So it's going to be x to the -1 divided by -1. We'll make it pretty in a little bit. And then plus, I guess I'll write 2. 2x, and then -3 plus 1 is -2, and I'm going to divide by -2. And then plus c. All right, let's make it pretty. ln, absolute value of x, minus 1 over x, minus the 2's cancel out, 1 over x squared, plus c. There it is. That is your antiderivative. How do we feel, guys? All right, that's it. You just have practice on Delta Math. Just practice your craft. And if we see each other tomorrow, we will do a handout. Good job, guys. Good day back. Go team.